Okay, this is the third video, right? We're finding the measures of angles, right? Using trigonometry and our calculators. Find each angle measure. Okay, let me go over the first set of problems that you'll see here. And sometimes they'll use the angle symbol, like sine of an angle is equal to 0.7986. Sometimes they'll use the angle measure, but sometimes they can use just any capital letter, right? So here on the assignment, it's using capital letters. It doesn't matter which capital letter they use. It's just treated as the angle, right? So here on the notes, I have one that says sine of, and instead of this angle, it says W. Sine of W is equal to 0.7986. Well, that's the angle. Your W, or whatever letter they have here, that's the angle we're trying to find. Right, this one here. Okay, well, pretty much you already have a number here, and I want to get W by itself. So what have we been doing to solve for the angle and to get that W by itself? Remember, to find this angle measure, I have to undo this sign, and you take the inverse of both sides. I take the inverse of that, which means these cancel out, and I got to take the inverse of this side also. And in this case, it was sine, so it's sine inverse of this. So you get the W by itself. The angle by itself is equal to, and then here's the part where you just got to do this in the calculator, 7986. Here's the part where now you got to do this in the calculator. And you'll get W is equal to, well, let's see. Turn it on first. Sine inverse is, got to use this button here, sine inverse. Make sure it has that little -1 exponent of, and I just type in this decimal, 0.7986. And then make sure you close the parentheses, and then you hit enter. It says 52.99. 52.99, I think we can round that up. I think we can round that up to 53 degrees. 53 degrees. If it's super close like that, we can round it up. 52.99, 53 degrees. Okay, that's how we do it. Let's do another one. Number 2. What if it says tangent of x is equal to 3.7321. Remember, this is your angle. So they forget to put the little degree sign, but that's what you're trying to find, the angle measure. Tangent of some angle is this. What angle measure is it? Right? Oh, by the way, you can always check this, right? We got an answer, 53 degrees. You can always put sine of 53 and see if it gives you this, right? We're saying that sine of what angle is this? Well, let's check it. We didn't check it. If I come back and I put sine of, and what did we get over here down here? 53. Hit enter, and it should give you 0.7986. I mean, it'll have other numbers. 0.7986, right? 0.7986. Right? You can always check and see that it's giving you these close decimal values. I'm trying to see what angle gives me this. All right, well, since this is tangent, what do we have to do? We got to take the inverse of both sides. Take the inverse of this side, take the inverse of this side. I mean, mathematically, that's what's happening. These will cancel out. Tangent and its inverse cancel out. That's why you're left with only x, the angle that we're trying to find. X is equal to And then this is where you just got to do calculator right here. Find the tan inverse of 3.7321. Okay, calculator time right here. It's all about the calculator right here. Don't mess up here. Let's see. Tangent inverse, I gotta hit this blue button first. Tangent inverse, there it is. It has a little negative exponent right there, -1. What was it? 3.7321. Close the parentheses and then hit equals. 75.000. That's like 75. 75 degrees. According to this, 75 degrees is the answer. The angle, right? Well, let's check it. If I'm claiming that 75 degrees is the angle measure, well, if I take just regular normal tangent of 75, does it give me close to this number? Let's see. Tangent of 75 equals. You guys see it? I'm checking it. Did I get the 3.732? And I didn't get the 1, but you know, this 5 will round this up to a 1, but yeah, it's close enough. Okay, that's how you do that. That's how you figure those out. Let's do the ones that are going to be given to you with a triangle. All right, so let's try this one. Here's number 1 for these. What if you have a picture like this? Right, this is for right triangles. Here's the angle that I don't know. I mean, I can use this, or they actually have the ABCs. They have it like ABC like this. But what's going to be true is you're going to be given 2 sides. Here, that's 11 and that's 6. That's what I need. See, I don't have any one of these angle measures. I know this one's 90, but I'm trying to find one of these. I'm going to find this one. I can use this angle, or I know it's angle A. Whichever one you want. This is angle A, or this is our regular looking normal little theta. This is theta, angle theta. How do you do it when it's like this? Easy. You label your sides. This is what? We've done this before. This is your opposite. This is, well, we label hypotenuse first, but we're not using the hypotenuse side, right? We're not using this hypotenuse side. That's the opposite, that's the adjacent. That's how you'll know, right? We've done this before. And then you write what? So, ka, toa. Which one has the O and the A? Well, this is how you know which one you're using. Not using cosine, not using sine. Just like before, same thing. So you're using TOA. That means what? That means tangent of the angle is equal to O over A. And I don't know the angle, so that's why I'm just going to leave it like that. Tangent of the angle is equal to, what's O? 11 over 6. Opposite over adjacent, 11 over 6. And then see, here is where now, if I'm trying to find the angle measure, that's where you need to get rid of the function. How do we get rid of a function? We can't divide it. You have to use the inverses. So I take the inverse of this side, and I take the tangent inverse of this side. Oops, I got kind of close right there. Tangent multiplied to its inverse will cancel out. That's what happens here. And that's how you get the angle by itself. And then what's left here? Well, you got to figure out what tangent inverse of 11 over 6 is. And here's where you go to your calculator. Here's the part where you do the calculator piece. Okay. And what do we do if it's a fraction? It's the same thing, right? I'm going to first go second function, tangent inverse. Remember, you got to hit this blue button or purple button. And if it's a fraction, just put 11 divided by 6, right? In this case, it's 11 divided by 6. And then close the parentheses. And then you hit equals. Equals. There it is, 61.38. 61.38 degrees. So that's going to round off to what? I think they rounded off to, I mean, I would just leave it like this if I was you, 61.38, 61.39, but they show it, the answer key shows it here. I mean, I'm going to write 61.30, you could put 38, you could put 39, whichever one you want, right, because this 9 bumps this up. This is what I would want you to do, 61.39, but the answer in the...
Good morning, Gallegos. Good morning. This is Mr. Tejada.
Hold on.
Ladies and gentlemen, I will be teachers. I will be and all staff members.
Okay, where was I? There was an announcement. Oh, this is what I want you to put, but if you check the answer, you know, in the answer sheet here in your homework, it'll round it up to, this 9 will bump this one up, so it'll just say 61 point, see this 9 bumps it to a 4. That's okay. I'm not going to sweat that stuff. But I would want you to now, I would leave it like this. Either one's fine, okay? Either one is fine. All right, let's do a couple more. Okay. So, let's do another one. Here we go. So what if you have something like this? Here's number 2. The ones like this. What if you have a triangle that has something like... Right, again, this is only on right triangles. It's going to have a 90-degree angle. And obviously, this is the angle they're asking you to find here. Excuse me. And this is a 7, and this is a 12. Excuse me. Well, again, let's see. What do we got? Oh, we label our sides. This is the... right, I don't know the angle. That's what you're trying to find. That's what we're learning here. We label the hypotenuse side first, and we're definitely using that one. And we're also using the opposite side. Which function has the O and the H? So, ka, or toa? Which one? So, ka, or toa? Remember, just like before, OH is right there. So, I'm not using this. I'm not using this. So that tells me that sine of the angle is equal to O over H. I don't know the angle. That's what you're trying to find. So sine of the angle is equal to O, 7 is the opposite side, and H is 12. Okay, we got this right. And then now how do we finish this? How do I get the angle measure? Remember, I have to undo this sign. This sign right here, I got to get rid of it. I just want the angle alone. Oh, I put this too close again. Bottom line is you take the inverse function of sine, and that'll cancel here, and you take the inverse sine here. Oh, I put it too close. You take the inverse of this one. So when that happens here, what's left here? The angle. See, I want that alone. The angle is equal to sine inverse of 7 over 12. That's calculator time right there. Calculator time. And let's see. Clear this. Second function, sine, to get the sine inverse right. 7 divided by 12. Leave it like that. Close the parentheses. Hit the equal sign. I got 35.68 or 35 point maybe 69. 35.685, but the 5 bumps up the 8, so I can put 30. This is going to be fine, but most likely in the worksheet it'll be 35, and then see this 9 bumps up this 6 to a 7. They round off a little more. That's fine. Either one of these is fine. Okay, that's the angle measure right there, 35.7 or 35.69 degrees. All right, last one real quick, number 3. Let's see, which one do I want to do? All right, what if it looks like this? Got this triangle facing another way. That doesn't matter, right? Oh, that doesn't matter which way it faces. It's a right angle. Angle's up here now. I got 6 and I got 12.1. Oops, sorry. Right there. Pause it, copy it, rewind it. That's a good thing about the video. Okay, label your sides. That's how you're going to know which function to use. So this is the hypotenuse side. Yes. Opposite side we're not using. So it's the adjacent. It's the adjacent on the hypotenuse side. Right, that's where I got numbers. I don't have anything here. That's how I know I'm not using that. Which function has the A and the H? Ka, right? Right, we got so, we got ka, and we got toa, but the one that has the A and the H is ka, this one. That means that what? That means that we're using cosine of the angle is equal to A over H. That means, I don't know the angle, I'm trying to find it, right? Cosine of the angle is equal to, what am I going to put here? A, 6 over H, 12.1. And let me take it over here. And what do I do here? Cosine of an angle is equal to, and now I'm going to put some space, 6 over 12.1. This is where I want to get the angle by itself. How do I undo the cosine? I do the inverse. I do the inverse of cosine to this side, which means you do the cosine of inverse of this side as well. And that's how you do it. And that's why it happens like this. So here, cosine and its inverse cancel out. You're left with the angle by itself. The angle measure is, and here's where it's calculator work. 6 over 12.1, or 6 divided by 12.1. Take that blue button, make sure it says cosine inverse, don't just push cosine. If you just push cosine like that and it doesn't have that little negative one, that you're not going to get the right answer. Make sure you go get the inverse. Cosine inverse of 6 what does it say here? Did that help? Six divided by 12.1, and then close it. Can you guys see that? I know it's blurry right there. Hit equal sign. I got 6.27. I'm sorry, I said 60.27. I got 60.27. That's the angle. 60.27 degrees. That is the angle. Again, the worksheet might round this off to the nearest tenth, so it'll probably say 60.3 degrees. It's still okay. All right, that's it. Hopefully that's easy for you right there.